So hi there, I'm Emily Dunham. I'm the DevOps engineer for Mozilla Research, so I get to hack on Rust infrastructure a bit. I got into the project since just before 1.0 came out in 2015. I mostly actually write Python for my day job, but I play with Rust, organize a Rust meetup, and teach introductory Rust workshops at conferences here and there. I'm going to talk about a lot of different things today. I'll do my best to speak slowly and clearly, but I sometimes use long sentences when I get excited about something. There's a few places through this talk where I'll switch topics, so I'll mention that it's a good time to tune back in if you got lost in the previous section. So I'm from Portland, Oregon, and this is my first visit to Kyiv. Where I'm from, we only know about the past 200 years or so of history. So I find it amazing to visit here because people know what happened hundreds and even thousands of years ago right in this place. Visiting buildings that are almost 1,000 years old makes me think about just how new computers are. I'm going to start with a bit of an origin story, then get on with the fun and argumentative parts about Rust. If the origin story bores you, you can take a quick nap till you see the Rust logo on the screen. That beautiful machine is an IBM 7090 computer. It took up a whole room, and it was state-of-the-art when it came out in 1960. It cost $2.9 million US at the time, which is a lot more now. It could perform 100,000 floating point operations per second. We call those floating point operations per second flops. So does that sound fast? Pretty fast? Well, a first-generation Raspberry Pi, the little thing that everybody builds their toy projects with these days, was over 40 times faster. So we have a museum-quality computer right there. How did things get better? You can improve a program's performance either by changing the hardware you run it on or by changing the software. For a long time, we just basically changed the hardware to make computers better by stuffing more transistors onto a chip and running instructions through the system more quickly. We build bigger, faster computers, and as they get cheaper, we can throw more of them at a given problem. Gordon Moore quantified this growth in 1965 when he coined Moore's Law. Moore's Law said that the number of components on a chip would double every 18 months. Doubling the number of components on the chip every 18 months meant that computers got twice as powerful while fitting in the same space. However, there's a few problems with this. First, the laws of physics say that eventually you can't make a component any smaller than a certain size. It also gets more expensive to build smaller chips as you get close to those limits. But customers, the people who use and buy the computers and keep the computer manufacturers in business, don't care. Programmers keep writing bigger and more complex programs. And as long as the new computers are speeding up more rapidly than your software is growing, things seem to be improving. When a program needs a bigger and newer computer to run it, what happens to the old one? Well, it might get handed down to someone else or resold, or it might get thrown out, and this is not great for the planet. Plus, having code that only works well on the newest devices is not great for people who can't afford that state-of-the-art. Additionally, if you're a business, you have a problem, because you have to get your code or website to work on whatever people are using rather than what you wish they were using. So if your program is too slow, they might not be your customers for very long. So people want their computers to keep getting better, but just making the hardware faster is not nearly enough anymore. And throwing more hardware at a problem can get very expensive. Hardware engineers are still trying to fit more parts in the same space, but it's getting slower and more expensive as they get closer to the limits of what physics allows. As well as changing the hardware, we have to change the software. Cloud architectures let us run out code on a bunch of computers at once and pretend that it's one big computer. But we still want the whole system to be fast. Systems programming languages are great at letting you turn time and effort into faster code instead of just saying, well, buy more computers. However, systems languages tend to be challenging to learn. You have to tell the machine exactly what you want it to do, so it's easier to tell it to do the wrong thing. Historically, this problem has been addressed by telling the programmer some rules to follow, and then blaming them when they inevitably break those rules as the system gets more complex. There have been other languages with similar safety rules to Rust. In fact, they're where we learned a lot of our tricks. But those languages have historically been very slow and often difficult to use. Rust is a language that combines speed, safety, and concurrency and makes many people fall in love with it. So a whole bunch of people contribute to Rust. Anyone who wants to make a change to Rust can follow the contributing guide. It does say where you should submit your patch to, if Manish's just around here. And they can see if their idea will work. And new people are joining all the time. This graph shows the total number of unique contributors by email address at the start of each year, and also this weekend, so we're about a quarter of the way into the year, about a quarter of the new contributors we might expect. So note that when I show you graphs about contributors in the talk, I've counted people as one email address as one person. This isn't perfectly right, but it's about as close an approximation as I can get without going into some major identity and tracking who's who complicated issues. So we've also been growing in terms of code base size. Rust has a lot of people writing a lot of code. This shows how we've steadily been making more code for as long as Rust has had a Git repo. Note that the rate of new commits per year is pretty steady. Rust 1.0 came out on May 15th, 2015, but we don't see a drop in contributions after that milestone. New features and bugs keep hitting Rust's nightly channel every day. Bug fixes and backwards compatible features trickle into the beta and stable branches to be released every 6 weeks. And as well as individuals, Rust has a growing fan base of corporations. There were about 63 companies that publicly share that they depend on Rust when I took this screenshot of the Friends page yesterday. I think our adopters represent an impressively diverse selection of the tech community. Rust is used at companies ranging from brand new startups to those that are household names. Plenty of people who don't even know that Rust exists are indirectly benefiting from it if they use software from users like Mozilla and Coursera and Dropbox. And as Ashley mentioned in her talk before lunch, Rust people are pretty well known for liking to talk about Rust. Later, I'll get into more details of how I think you can succeed at promoting Rust. But first, I'd like to share a tip for the first time you talk to a potential new Rustation. So, pop quiz, what's the first thing you should tell to someone who isn't sure if Rust is right for them? Now, we'd take half an hour if I had everyone shout something out. So, I'll tell you that that was a trick question. You shouldn't start by telling them anything. You should start by asking questions. You should learn about the needs of their project before you try to claim that Rust is going to solve whatever problem that you don't even know about yet. So, ask them what they're trying to do, and think about whether Rust is actually a good fit. Respect that while Rust is a great solution for a lot of problems, there are a lot of times when it may not be the best answer available. So, when should somebody choose Rust? Here's some questions to ask yourself as you're talking to a potential user. First, does their application run on platforms that aren't supported by LLVM? If they do have that LLVM support, it's a manageable amount of work to get Rust running on it if it's not already supported. But if that's not there yet, they might be better off waiting a bit until it is. And how would they go about bringing Rust in? We've got a lot of options, as you've heard about through the day. Maybe they rewrite a component. Maybe they use SFI, foreign function interface, perhaps with some help from the bindgen tooling to bring it in. Maybe they use the corrode tool to translate C code directly into unsafe Rust and then iterate it from there. So think about what adding or switching to Rust would look like before you just tell them, go do this thing. Additionally, there are some less technical but probably more important components to whether Rust is going to be a real hit with a team. A couple of the big ones are, do they have time right now? If you have a team that's super great at Java, and they're halfway through building this Java app that needs to be released next week. This is a terrible time for them to switch to Rust. And are they interested? If you're dealing with a culture that would just conflict with Rustaceans, where they wouldn't get along with the way that we ask people to ask questions, or they don't want to work with an open source tool, adding Rust or attempting to add Rust into the mix may cause more problems than it solves. So there's also a situation where sometimes somebody will have a problem that looks to you like Rust is obviously the answer, but they just think it's not that great. So why would somebody think that Rust is uncool? Well, for one thing, safety sounds really boring. So hear me out here. If you were lost, you can tune back in here. I'm going to have a little bit of a fun little rant. So this wouldn't be a proper keynote, in my opinion, or I wouldn't feel like I'd really given a keynote if I didn't take the opportunity to share one of my hobbies with you. That seems to be a thing that keynotes at most conferences do. So I'm currently in training as a volunteer firefighter. I took that photo of some others on the department putting out a house on Thanksgiving of last year. So I put out metaphorical fires in my day job as ops, and then I go put the wet stuff on the red stuff, as we call it, in my free time. When people find out about this, they often think it's pretty cool. Heck, I think I heard somebody clapping in the back when I said, "Hey, look at me, I'm a firefighter." Firefighting seems like a glamorous hobby. You're this hero who braves a dangerous situation to save the day. So firefighters seem cool for showing up to dangerous situations. Behind the scenes, back at the department, all of your training is about how to promote safety and how to avoid getting harmed in the line of duty. But that's not how the world sees you. I brought firefighting into this as an example of how just doing the safe thing all the time sounds a lot less boring and a lot less prestigious than taking risks. I think that's because for most of human history, risking danger has been the only way to get these amazing, newer, better things. For instance, for many, many generations, explorers had to risk life and limb and maybe drown or get, I don't know, eaten by a tiger to discover new places and new foods and new people to trade with. Even today, a lot of the cool new things that we get in the physical world require a lot of risk to get to them. We're getting better at turning human risk into risk for other systems. For example, the Curiosity rover risked terrible accidents and will be stuck on Mars for the rest of its life, all to bring us a bunch of new data. That's the opposite of staying safe. So tech has an advantage over the physical world. You won't get eaten by a tiger if you climb up the wrong branch of your Git tree. You won't crash into a planet if you mess up a product launch. But tech culture doesn't advocate for metaphorical safety. One of the first things you'll see when you start reading blogs or watching talks by people who build new technologies is this advice to fail fast. It sounds like pretty good advice. Just like a lost item is often in the last place you look, the best solution is, or the solution you're looking for, is often the last one you try. So the quicker you try a bunch of solutions, the sooner you'll find the one you want, right? So taking risks and failing fast look like the path to success. How will you know when you're doing this failing fast thing right? So do you see how some people might get the impression that picking a language that lets your code break a lot is actually kind of going the right way? I mean, safety is boring. I see you all giving me this look right now. This owl, the symbol of wisdom, is looking at me like he thinks I'm being very unwise indeed. Now, you as people who think that Rust is awesome enough to spend your Sunday at a conference about it might already know that there are different kinds of risks that software can take. You might think, and I hope you think, that boring and predictable code is wonderful. But you haven't always known and believed that. If you find yourself trying to sell Rust to someone who just doesn't think that safety is valuable right now, it's okay to politely disagree with them, and it's okay to walk away and come back once they decide, wait a minute, I'd rather have less fun adventures at 2 in the morning when production falls over. So Rust is not the right tool for everybody. It's important to figure out what somebody is optimizing for before you evangelize it to them. What kind of change to the project would they call good? Different users do have totally different needs and totally different requirements from a language. Maybe there's somebody who thinks it would be best to pick a brand new, totally bleeding edge tool so that they can learn new things and get the respect of all their friends for having been there first. Or at the other extreme, maybe they think it's best to pick the oldest, most established tool that they can find so that they can purchase a support contract and have legal accountability from someone. Neither of these use cases is wrong, but you have to recognize that they are very different from one another. But I would contend that for anyone, having safe code means that you can take the better kinds of risks. I think that memory safety will improve any systems programming project, but my argument about danger and progress and the glamour of taking risks was not entirely a joke. If you were lost, come on back. I'm less on the sidetrack now. So the story of how Rust is spreading around the programming world is a story of individual people taking risks. The first big risk that any Rustacean takes is to put in the time to learn the language. You could have put that time into another language. You could have gone and learned a sport or a musical instrument or spent more time with your family in the time that you've spent studying Rust or even coming to this conference today. And there's always a chance that you might have liked that more. So you have taken a risk on Rust just by being here or just by watching this recording and spending an hour or 40 minutes of your life on it. So the second big risk that a lot of Rust people take once they're more comfortable with it is to bring it to their projects. Most people who bring Rust to an organization start off as the only person there who knows the language. They become the representative of the language to their colleagues, and they volunteer to answer a lot of questions where they might not even know the answers yet. So everybody here has taken a bit of a risk in order to promote the Rust community. So thank you. So are you running a Rust project or bringing Rust into an organization? You might have been amazed and jealous when you heard the stories about having too many new contributors, having the Rust code just run too fast and cause problems. If your code is open and you've got a bunch of easy bugs, but none of those metaphorical piranhas snapping them up, you can try filing those easy bugs on an issue aggregator site to get them some more visibility. Here's a bunch of sites. Snap a photo or grab the link to my slides from the final slide to get those clickable links. And another great way to network, reach out, feel less alone in your Rust progress is to find a local meetup or a conference like this one. So now we've talked about growth, and we've talked about safety and danger and taking better risks. Before I hand things back to the team, I'd like to make sure that everybody has the resources available to succeed in the Rust ecosystem. If you've been here a while, look at this as a refresher in the cool stuff that newcomers don't necessarily know about that you can share with them when they ask you questions. First off, Rust project cultures tend to look a lot like the culture of the compiler's development. All of Rust's development is done in the open. From the forums and IRC conversations to the request for comment process, it's easy for projects using Rust to see how the compiler does its business. If you've gotten involved with these open conversations, you might have noticed that we used discourse forums instead of mailing lists for general discussion. We chose forums not only to make moderation easier, but also to make simultaneous conversations easier to follow and to find information in later. So I think that good practices that people like, trickle down into the projects that use the compiler. People get familiar with the developers' workflows, and then they cherry pick the bits that they're fond of and bring it back to their own work. This is especially easy with Rust because in addition to the open communication, we focus on using open tools. The bots that you see helping out around the Rust community, like High5 and Homu, and the documents like the Code of Conduct are openly licensed. You can take anything that you like about how Rust gets built and copy it to building your own project. So one popular practice of Rust is adopting a policy that people should communicate constructively and generally not be jerks. We call these the codes of conduct, and I think that they work in Rust and its derivative communities for two really big reasons. First, we've had them since the beginning, and projects tend to clarify their expectations about conduct right when they're starting out. This is important because if a potential contributor thinks that the conduct expectations are unfair or not something they want to abide by, they just don't get started with the project. So we end up with a group of only people who think that it's either okay or awesome to behave this way. And second, we have an amazing moderation team to make sure that the codes are fairly enforced. Saying, we'd like people to be constructive without any enforcement is like saying, I'd like my code to be faster without actually refactoring or optimizing it. The second practice that Rust projects often inherit from the compiler is to have a good test suite that runs before the code lands. Graydon, the inventor of Rust, calls it the not rocket science rule of software engineering. Graydon used bots named Monotone and Boars to enforce this rule, which is why the bot account that Rust uses keeps the name Boars to this day. The not rocket science rule states that you should automatically maintain a repository of code that always passes all the tests. In Rust and Servo, the robot that does this is called Homu. Once a human says they want the code to land, and a human says they want the code to land by commenting R+, Homu runs the tests and then only lands that code into the master branch if those tests pass. Not only does this policy keep the master branch of the repo in a good state, it makes code review a lot easier. Instead of forcing a maintainer to say no to code that fails the tests, we use a robot. This shifts the dialogue from, that maintainer is mean and wouldn't land my code, to, that robot sure is picky, but the maintainer was able to help me get the code through. And no discussion of the things that people enjoy about Rust would be complete without mentioning cargo. The package manager makes it easy to publish for others to use. So cargo was partially motivated, as others have mentioned today, by frustration with the way that other package managers behave, and it's a real hit. However, the ease of publishing crates introduces some challenges. Everyone who re-implements a popular library as a learning project gets to publish it. This means that there are often many crates for similar purposes, and it's not always clear how they're different or which one you should use. So an ongoing challenge for Rust accessibility is for people to be able to find which of the similar crates they actually want. Categories have recently been added to crates.io. You can see the popular categories list there, although it turned out to be a bit of a small font. And they make it easier to compare the various crates that do similar things. Another good way to guess what crate to start with is to just take a look at what your favorite projects are using for a given task. And if you're still stuck, you're always welcome to ask any question on the users.rustlang.org forum or on IRC. You'll get the best answer, of course, if you clearly explain what you're trying to do and what options you've already considered. So publishing crates is one of the most visible ways that Rust users contribute back into the project's ecosystem. When you publish a crate for others to use, it's rarely very much work to include some basic documentation. Start with making sure you have a README that describes what your code is supposed to do and what it actually does, how close to your goal you are. And make sure to add a contributing file to tell people who might want to help how they should. If that contributing file says, this is a side project, I don't particularly want to deal with it because I'm done, please use that other crate instead, that's okay too. If you're publishing a crate and you want other people to use it, please check that you have a license on your code. You can set the license or specify a license file in your cargo.toml the way these docs describe. Many organizations and projects aren't allowed to use unlicensed code because often local laws say that code without a license that frees it up is copyright of its original author and no one else is allowed to do anything that copies it. So be kind to people in those jurisdictions, even if you're not in one, by making sure that you clarify what you intended by sharing that code. And Rust's incredibly vibrant international community exists in person as well as online. So this community is built by the people who organize and attend its many meetups and conferences. Yeah, that's you. So new Rustaceans who want to make friends and ask questions should check if there's a Rust meetup near them. You can also start a meetup or help someone start a meetup if they haven't got one yet. Oh, that's a map of the globe. You can imagine that the first cluster is in North America, the other cluster is in Europe. We've got various points all the way down the east side of Asia, some in India, some in Australia and New Zealand, and some on the east side of South America. So we're not in every country yet, but we're getting there. So another important way that Rustaceans get involved in the ecosystem is to provide ideas and feedback on the language's direction. The language is shaped by user contributions through the RFC process, as well as through bug fixes and other code. It's described in more detail in the contributing guide if you haven't read through already. And remember that you can always, no matter who you are, you can always suggest a change. But changes will be scrutinized to make sure that they won't break things for other people. There's volunteers all over the world making up Rust's 9 official teams. Each team has a mailing list where you can direct questions about their area of expertise, and most teams have an IRC channel as well. If you have a question but you don't know where to ask it, you can always hop into a Rust Beginners channel on Mozilla IRC. You can ask on users.rustlang.org, or if neither of those work, you can shoot an email to the community team asking where you should find the answer to your question. The more you tell us about what you're trying to do, what you've tried, and what happened instead, of course, the better we can help you. So the community team also has a site where you might be able to find the answer to your question before you ask it. We aggregate all kinds of resources about getting involved with Rust and the various Rust projects. So if you notice something missing from the community.rs/resources page, please help us add it. Submit a PR or an issue saying, there's this cool thing you don't have yet. So this whole community thing, who's actually building Rust? Like, is it a Mozilla project? I know Mozilla funds it a lot. Well, community is basically the entirety of the project. While Mozilla sponsors compiler development by employing some full-time staff, almost all contributors are from outside of Mozilla. If we guess that a contributor's email address represents where they work, there's some error because a few Mozillians might use a personal address. There's also some error because some people at Mozilla who aren't paid to work on Rust might use their work address. This pie chart speaks for itself. The whole Rust compiler repo has 39 unique contributors using email addresses at mozilla.com and 2,033 contributors from other places. So that's cool. Maybe we just get a bunch of drive-bys. If you break it down by who wrote the commit, instead, you see about the same story. Less than a quarter of the commits come from people who might be working on it full-time as well. Rust's technical progress, as well as its online popularity, is driven by you, the community. So you probably already liked Rust since you're at this conference. I hope that stepping back to look at why we've got Rust and what we get from it has been enjoyable or educational as a way to wrap up. If you did get lost, tune back in, because I'm about to recap the 3 key points from those sections. So one of the most important takeaways is that Rust is growing up, and Rust is ready for and used in production. So first, you need to demand that your computer do everything it can. When throwing more machines at it or running things on a faster machine won't cut it anymore, it's time for a systems language, and Rust is an excellent choice. So use the tools available or build new ones to improve your code's performance. Next, share what you learn. Find a way to help others benefit from the time that you spend on Rust. That might mean mentoring, writing blog posts, or filing issues with projects or the compiler. And finally, keep on building the code and the community that you want to work with in the future. Thank you. So I know we've got quite a few announcements and other things from the team, so I will hand the stage back to them.